Good morning. Can you hear me?
Yes.
Thank you. Thank you. So, as you see on the screen, that today we are going to talk about a very important topic of logarithm. To motivate you a little bit about why we need the notion of logarithm in the first place, let us go back to a very simple example. So, if I ask you, do you remember last time we talked about exponential equations, an equation in which the unknown jumps into the exponent and then you're supposed to find that x? And of course I presented a few examples that you were able to solve those problems without any further knowledge of mathematics. The reason that why that was easy to solve, because all those exponential equations were reducible to a form on which you have two same base on the sides of the equation. For example, 2 to power let me just clean this. 2 to power 5x, for example, equals to 32, and then instead of 32 you were able to write 2 to power 5, and then you say that two powers of 2 are the same, so it implies that the exponents are the same. So then you get this equation and you were able to solve that equation and find your unknown value for x. Of course we were able to solve a little bit harder problems, but most of all of them were reducible to this kind of equations in which you have the power of the same number on both sides, and then you were able to compare the exponents. But now let us start with a very simple example today. For example, if I give you 2 to the x equals to 4, you really don't need to be advanced in mathematics. You immediately say that, okay, this tells me that 2 to the x is equal to 2 to the 2, and then it implies that x is equal to 2. But let me now start with a very simple equation. But what we can do now?
Ustad,
yes?
Pardon. The only thing that we see is your Geogebra screen, so I don't know if you're writing somewhere.
Yes, I am writing. That is very strange. Thank you for letting me know. Let me try to fix that.
Yeah.
Okay, so let me repeat. 2 to the x is equal to 4. We were able to solve this immediately and say that x is equal to 2. Let me change the equation just a little bit. By little bit I mean change 4 to 3. Okay, then if you ask me, give me that x, I cannot give it on top of my head unless I use the notion of logarithm that I want to talk about today. But first of all, here it was not hard to see that such an x actually exists, because it was so simple that I was able to guess that. Can you tell me, using Geogebra or whatever, first of all, do you believe that such an x should in principle exist? Or
yeah.
How do you say that? How do you think that this should be the case?
Well, as long as it's a real number.
No, you need to give me real mathematical arguments.
Well, I mean, I can't say more except for that there is a number that we call logarithms.
No, we don't know logarithms. I just want you to learn the logic. The logic is exactly what I am describing for you. This problem guides us towards a new notion called logarithm. But what I am trying to say, for example, let me just think in this way. If someone asks you what is a square root of 2, what is your answer, by the way?
Square root of 2.
Yes?
So square root of 2, I mean, it's what you call an irrational number.
No, these are properties of a square root of 2, but what a square root of 2 itself is?
The square root of 2.
No. You just give me some ideas. Pardon?
It's an operation.
Taking a square roots is an operation, but a square root of 2 is the product of that operation. You are right. A square root of 2 is the product of that operation. But now you have the product in its final form. If someone asks you square root of 2, what is the square root of 2? What's your answer?
Could you say the number that when you multiply it by itself becomes 2?
This is the exact definition. Thank you. You cannot say more than that. You can say that, okay, I punch square root of 2 in the calculator, I get a number. This is not square root of 2 that you see on your display. That's just an approximation to what really square root of 2 is, yes? The square root of 2 is a number so that when raised to power 2, as Rocco told, if you multiply it by itself, it becomes 2. That's it. This is the meaning of a square root of 2. But in principle, you need to ask yourself first, do you think a square root of 2, do you think such a number exists? Do you think, is there any number? Do you think that there is a number so that when I square it, it becomes 2? This first you need to convince yourself that such a number do exist. Yes, such a number does exist in principle, and then you should be able to give it a name. Okay, so you say that is there any number so that when I square it, it becomes 2? If in any way you can convince yourself the answer to this question is yes, then you can call this question mark, you can give a name to this question mark. In this case, mathematicians has chosen to give this the name of a square root of 2. And then they give the symbol for this. By the way, this symbol is coming from R, English letter R. Yeah, just a little bit exaggeration. So this is why we use this symbol for square root of 2. But what is my point? My point is that somehow, first, you should be convinced of this, that there is indeed a number with this property. When you are convinced that the number with this property does exist, then you are allowed to give it a name and a symbol to denote it. Okay? The same strategy is here. First of all, I want to give this guy a name. But first of all, I want to make sure that this is not something void, you know, it is real. If I want to make sure such a number exists, and I want to make sure such a number is unique, and then I am allowed to call it something, give it a name, and denote it with a symbol. If I am not convinced about that, well, what can I talk about? So now my question is that, in any ways that you have, using Geogebra or whatever, convince me somehow that such a number exists, the first thing. Convince me somehow that this number is unique. After these two criteria, then I am allowed to give this a name if I am convinced about the first two questions. Otherwise, I am not allowed to give it a name. Everyone knows, people know what is the meaning of a square root of 2. If there are more than one numbers with that property, then people are confused. They don't know. When you write a square root of 2, they don't know. Do you mean the first one? Do you mean the second one with that property? So be careful. The existence of such a number should be guaranteed. The uniqueness of such a number should be guaranteed. Then you are allowed to give it a name and denote it with a symbol. But now we are in the first stage right now. Don't go too far. Of course, this become extremely hard problem. If I want to solve it analytically, you don't have enough mathematics at your disposal. But understanding it using Geogebra or whatever, you have something to say about it, that you can convince me about existence of such an x and uniqueness of such an x.
Wait, what was the question?
The question is that, convince me first of all, let me concentrate. I give you this equation. First convince me. I don't want you to calculate something for me. First convince me that such a number does exist. Second, convince me such a number is unique. There is only one single number with this property that when you raise 2 to that power, it becomes exactly equal to 3. The first question, convince me that such a number exists.
So if you talked about GeoGebra,
Yes.
maybe we could write this as a function. So we could write y is equal to 2 to the power of x, and then we could find the point where y is equal to 3.
Thank you, thank you. Best answer, thank you. So we do this. We go to GeoGebra. I already put this, I made the cursor a little bit bigger, so hopefully you can see that. So what I have done, first of all, let me show, I have changed the grids because these exponential functions grow very fast. So you see each grid on the y-axis is not 1 unit, is 2 units. And each grid on the x-axis is 0.5 units. The reason that I made this because I want to make this exponential function a little bit more flat so that you can at least see up to point 16 here. Otherwise 16 would be out of my display. That's the only reason that you see different scales on the x and y axes, yes? Now, what Rocco said is completely right. We know that there is an answer to that. How? Rocco said that we let us, I don't know if GeoGebra is capable of doing that, but let me write y equals to 1 over 3, and then, yeah, actually, no, so I don't know why did I put 1 over 3, sorry, 3. Delete, so let us go again. Y equals to 3, and this is this line, and if you don't mind, let me change the color so it becomes more transparent. So let me make it, for example, this line. Okay, and now you see that this point here is 3. Okay, this point that I am pointing right now is 3, between 2 and 4, and this horizontal line is y equals to 3. These things should be simple for you by now. And then you see that I see an intersection point here. Yes? Okay, this intersection point is the, then I need to find the x coordinate. So I go to the intersection point. I find the intersection between this blue curve and this red one. Hopefully GeoGebra, yes, found it. So this is the intersection point. And then of course you see this GeoGebra is giving approximate values, forget about that. But I want to convince you that such a number exists. So what should I do? Let us do some game here. So for example, I go to this part of GeoGebra, you see it is written perpendicular line. Okay, so I choose this option, I choose this point, and I choose the x-axis. Okay, and then you see that GeoGebra draws a line passing through that point perpendicular to this one. Yeah, you need to learn these things. This is also very fun if you want to work geometry with GeoGebra. So now let me go, if I can find the intersection point is here. You see, yes, let me see if I can point exactly to this. No, yeah, so I have to use the rules, you know. So I will go and find the intersection point again between this new line, why it doesn't work, yes, and the x-axis, yes, this is B. And now what I do, I go to GeoGebra, and then I will delete, I will remove the object, okay, and then I go here and find the line segment, and then connect these 2 points together, okay, and then what I do, yes, let us do it somehow. I go and choose this line again, yes, and then let me change this style to the dashed ones, okay, so here everything is now perfect. Okay, so, and I think it's better to change the color as well to red. Okay, good. Now let me by the way change the color here as well. No, let me change the style here as well to dashed ones. Okay, now everything seems fine. You see this number that you see here, I am showing it with the hand, this cursor, it is 3. As Rocco said, I drew a line parallel to the x-axis from that point, and then I found the intersection, and then I went backwards. This point is somewhere between 1.5 and 2, but this exists. This is important. Do you think by this method I can get more than one point B? No, because of the behavior of the function. Yes, the behavior of the function you see is a monotone function. It's going up, up, up. There is no returning back. So when I draw a horizontal line, I will get exactly one intersection point. This is guaranteed that I will get an intersection point, and this is also guaranteed that I will not get more than one intersection point. So this number that you see here, 1.585, is an approximation to this number that when I raise 2 to that power, it becomes 3. So remember this number 1.85. So now if I go back to this screen, so you will see that if I ask you what is this, what we learned from GeoGebra is that this number is approximately 1.8, I don't know, I forgot, what was that? 1 point something like this.
585.
Yeah, 585, something like this. But this is still approximation. My point was not finding the approximate value. My point was, by this geometric method, to convince you that first of all, such a number does exist and such a number is unique. Now save my breath if you understand these 2 points. Did you?
I think
Yes.
so. I'm pretty sure.
Yeah, okay. Thank you. Thank you. So what I do, let me by the way do this trick and then save it to my iPad here. Don't need that much. Okay, so now let me show you something here so that I can write on it. Okay. Okay, so now I transferred that picture into my iPad. Okay, so let me just now show you what is going on. So this point here was 3, and what I did, I drew this line until this intersection point and then went back. There is a number here. This number is called the logarithm. The logarithm of 3 in base 2. You see, now I'm convinced. Be careful. The situation is exactly like a square root of 2. Now, at least by the graph using GeoGebra, I was convinced that there exists one number, exactly one number, so that when I raise that number, when I raise 2 to that number, it becomes 3. Then, when I know this number exists and it is unique, then I am allowed to give it a name. Mathematicians call it the log of this number in base 2, and they denote it by this symbol. So they write log for some strange reason. Your book show it with lg. I don't know why. This is not standard at all. So log, and then you put 3 exactly on the same base line, and then you put 2 as a subscript inside the log symbol. And this is the number that if I raise 2 to this power, it becomes 3. At least you are convinced that for this number it works. Okay, so let me now write this information here. This number is called log of 3 in base 2. Is that understandable?
Yes.
Okay.
Yes.
Good. Now, yes, hopefully. Yeah, you need to be confident, okay? Because when you say what?
Could you explain base 2?
No, this is the symbol. It's for example, this is this question that you are asking. You are asking, please explain this sign for a square root 2. This is the way that we write it. Do you remember when you write the third root of 2? What is the meaning of the third root of 2? It means a number so that when I raise it to power 3, it becomes exactly 2. And that's the same question. You don't ask explain 3. This is the symbol that I'm introducing. There are two numbers involved in this problem. One number 2 is the base. One number 3 is this output. Okay? So if you want to give this a name, it is better to involve these two numbers that are important. And mathematicians has chosen to give the name log instead of giving a symbol like that to it. And they have chosen to put this output in front of log and to put this number a little bit lower as a subscript. That's it. Okay, so let us continue. It becomes a little bit more clear. Otherwise, you can ask me again, Gustav. Okay.
Okay.
Now let me test your understanding. Let me test your understanding here. I don't know which one should I start with. Can you tell me, without anything, just what I explained, can you tell me what is the answer to this? Using this idea, I only accept your explanation if you explain it based on what I have told you right now. Without calculator. Let me ask you, if you ask me, can you give the number to this without calculator, I would say no. I will not be able to give you the value for this without calculator. Exactly similar to the question here. Can you give me the exact value of this without calculator? No. But can you give me the exact value of this without calculator, everyone?
Yes.
What is that?
2.
This is 2.
It's 2.
Because 2 to power 3 is 8. So there are some extreme cases here. Sometimes we can calculate without calculator. But can you give me what is the number here that I have to put?
Yeah, it's 2.
No.
3.
It's 3.
It's 3.
Sorry.
It's
Sorry,
3.
it's 3. It's 3.
Why? Because what I have to do, I have to start from 8. Yes? What happened to this? Okay. I have to start from 8. I go at point 8. I draw a horizontal line. I intersect here and I go down. I reach to which number? I reach to number 3 on the one hand. On the other hand, we learned that mathematicians call this log of this number 8 in base 2. So these two are different names for the same point, so they have to match. So you see, you have a good understanding without going any further. So you were able to guess that this log of 8 in base 2 is 3. Okay? Let me make it a little bit more tricky, okay? So what do you think about log of 1 in base 2? Just using this idea.
It's 0.
It is 0. But can you explain, Abdullah, why this is 0?
I said that.
Who was saying?
Alright.
Okay, so because I cannot see you, this is the problem. I'm just relying on my voice memory, and sometimes it's conflicted. Sorry for that. Anyway, why logarithm of 1 in base 2 is 0? Again, using the same method. First of all, can you tell me, let me make this a little bit bigger. Can you tell me which point is this point?
1.
Why? Why that is 1? The answer is correct, but why?
It should happen 2.
No, this is because it might be very close to 1, but our eyes cannot detect it. A very solid argument. Why this is exactly 1?
Anything raised to the power of 0 is 1.
Exactly, because this is your function. If you want to know what this x is 0, so instead of x you put 0, but you know that 2 to power 0 is exactly 1 by definition, so this is exactly 1. Yes? Not because it is exactly between, because exactly between is a vague idea for our eyes, yes? So this is exactly 1. So now what should I do? Can you tell me, according to this rule, I need to draw a horizontal line from 1. But when I do this, where is the intersection point? Can you tell me? Where is the intersection point?
At 0.
At this point itself. Yes? And when I go vertically down, I hit 0. So you are completely right. Whoever said that. So log of 1 in base 2 is 0. Are these things understandable?
Just to make it, it's not just for base 2, it's for any base.
Yes, let us come to that exactly. So there is nothing in particular for base 2. I have decided to work with base 2 because I can show the graph immediately. Because if I start with 3 or something else, they grow very fast. So I have to rescale a lot so that I can show you a good portion of the graph. Okay, let me ask you another question. Pardon? Yes?
Just to see if I understood it right.
Yes?
The reason it's base 2 is because it's 2 to the power of x, right?
May you repeat it again?
The reason it's base 2 is because y is equal to
Yes.
power of x, right?
Yes. If I
just wanted to double check.
Yes, thank you. If I consider this function, y equals to 3 to the x, of course the graph will go very faster, okay? Something like that. But then you are right. Every time that I have a 2 here, these 2's will be replaced by this 3. Yes, you are completely right.
Okay, thank you.
You're welcome. And now let me test you another way. So, for example, tell me by this graph, just approximately, give me the so what is the logarithm? Let me tell you. What is according to the picture in front of you, if I ask you logarithm of 10 in base 2, okay, I want to give me 2 numbers that according to this graph, I am sure that this lies between those 2 numbers. Can you tell me, according to this graph, logarithm of 10 in base 2 lies between which numbers as precisely as possible by these grids in front of you?
Yeah, I would say 3 and 4.
3 and 4 is correct, but better than 3 and 4.
3 and 3.5.
3 and 3.5, thank you. So it means that I start from 10, I go here, I intersect here, I go down, then I get something between 3 and 3.5. So yes, you are completely right. So it was a better approximation. 3 and 3 and 4 is also correct, but 3 and 3.5 is the best according to what we have at our disposal in this figure. So now you have a good understanding about the logarithm. Let me make it a little bit more challenging. Okay, so what is this one? Can you answer this to me? What is 2 to the power of this nasty number, okay? What is the answer to this? Do you need calculator to answer this?
Yeah, but we already went through it.
So what's the answer? No, there is no calculator needed. Just explain to me, what is the answer first?
It's 1.585.
No. The whole combination, this approximation is for the exponent. I am talking about the whole package.
It's 3.
It is 3, and is it approximately or exactly?
Exactly.
Exactly. Can you tell me why?
Because the log of 3 base 2, it's 2 to the power of x is 3. That's the log of 3.
Yes. So what you mean? The way that you are telling this, learn this. People say by definition.
Hold up now. I'm really confused.
Yes. Why?
Can you explain again why 2 of log 3 of 2 whatever is 3?
No, first of all, you need to read it properly. This is 2 to some power. This is a number.
Sorry.
And I am raising 2 to that power.
Log 3
Okay, because the answer is clear. If I ask you what is 2 to power 3 using the graph, what you do, this is 3. You draw a vertical line and go here, you find 8. So 2 to power 3 is 8. If I ask you what is 2 to power 3.5, you start from 3.5, go up there. When you found the intersection, you go here, I don't know, you get some number here that I cannot read. Okay, now I am asking what happens if you raise 2 to this power. You need to find this number is here, you go here and then go horizontally, you get 3. So 2 to power 3 in base 3 is 3 by its definition.
Okay.
Yes.
I think I get it.
No, this is something very new. I know this is a little bit strange. You need to get used to it. But this is not something very strange. You can see everything is transparent in this picture. So you see that you know a lot of things about logarithm before actually going through this officially. So is that clear, everything?
Yeah.
Okay. Now there is a name here. So the name here, do you remember what was the name of this number in an exponential function?
The base.
It was the base, and this is called the base again, because that's essentially the same number. This number, which was the base, is now transferred. This number is transferred here. So the name was the base, the name is still the base. I don't know if you have enough memory from what I told you. There were some limitations about the base when we were talking about exponential functions. Do you remember? So the exponential function is a function of this form. X is variable, a is a constant, but I told you there are some limitations for the base. Do you remember what was those limitations? There were 2.
It must be a real number.
No, real number is not a limitation. I told you that. We are always working. Yes, it cannot be 0, but this is not the only one.
It can be a negative number?
It cannot be a negative number, I told you, because if you choose a negative number, then you will be in trouble. If you choose a negative number and x is a fraction number, for example, if you choose a equal to -2 and you choose x equal to 1/2, then you will face -2 to power 1/2, which is a complex number not defined in the real numbers. It becomes a square root of -2, which is undefined. So a has to be positive. There was another important limitation. What was that one? No one? A cannot be a number. All positive numbers except
0.
no, positive.
1.
I have already excluded 0.
Maybe 1.
Yes, 1. Why? Because 1 to power x is not exponential. It's actually a fake exponential function. 1 to power x is a constant function. It's always equal to 1. So the graph of the 1 is just a horizontal line. Yes, it's not an exponential function. So remember this, please. The base of an exponential function cannot be negative, and it cannot be equal to 1. So it means it is clear from now that if I am going to talk about a logarithm, what you see in the base will have this property. The base is exactly the number that you got from here. This number should be positive and should not be equal to 1. So from now on, remember, if you talk about a logarithm, the base of the logarithm should enjoy the same 2 properties. It should be positive, it shouldn't be equal to 1. Otherwise, this symbol is not defined in the first place. Okay? Now, if you don't mind, let us go to another graph. Here, I started with this exponential function, but as Rocco clearly pointed out, there is nothing is particular or specific about 2 as the base. As far as this number is a number which is greater than 0 and not equal to 1, it works fine. So I don't know if we can just do it in GeoGebra. So let me go to GeoGebra. And then, for example, let me draw the graph of y equals to 3 to power x. Yes, and then enter. And you see now you have this red one. Okay, this red one is 3 to power x. Okay, so let me just don't spend time on writing it. So this red one is 3 to power x, as you see here. Okay, now if I ask you this question, that's the problem. Let me also copy and paste this one because I need to find a way to use the pen there. Yeah. Okay, so let me increase the height a little bit of this photo, and I capture this one and I send it to my iPad. Okay, so let me go to a fresh page and paste it here, make it a little bit smaller, and go back to the page that you can see it. Okay, so let us go back here. Okay, so this is, and by the way, probably Rocco, you are getting your answer. Do you see why I like iMac and Mac Apple things? Yes, they are working amazing. Yeah, okay. So I have a lot of tools when I am using these things together. Okay, so now let us see this. Let me write it here for you. So this is just y equals to 3 to power x. And now let me make it a little bit bigger so that you can see it here. Okay, you see now, if you remember, what was this guy here? This was the log of 3 in base 2. Okay, now let me ask you about this, about the log of 3 in base 3. You see what I have changed? I have kept the same number here, but I am changing my base from 2 to 3. So it means that you don't need to consider this graph anymore. You need to consider the graph, the exponential graph, whose base is 3, and I have already done it here for you. Now let us answer this question. Can you help me? Is there any volunteer to do that?
One.
Yeah, so what should I do? You know it exactly. Yes, thank you. Who answered 1? It's correct. So, yeah, okay, good. So between these 2 and 4, do you remember when I was drawing the graph of this, it was y equal to 3, yes? So this is exactly 3. So I start from 3, I go to the right. When I intersect with the red graph, I go down and I capture my number. So you are completely right. Log of 3 in base 3 is 1. Yes? So I hope that this is understandable for everyone. But for example, you cannot rely on your eyes. In this graph, might be you. Let me ask you, what is the log of 16 in base 3? Yeah, it seems 2.5, but it is not exactly. Yes, you see, if I don't know, even if I zoom it, it is not that clear. So it seems that if I go here and then go down, it is that number. So, but this is not correct, because I know that the answer is not 2.5. I will teach you how to do these things analytically. Definitely, I know that this number is not 2.5, but it seems probably a good guess, which is not correct. Okay, so you understand everything. So now you understand what is the rule. What is the meaning of logarithm? So why not we talk about logarithm in general? So what do I mean? I mean that, for example, you want to write a log. You should write a number in front of it, Okay, before doing that, let me ask you one question. Let me ask you one important question that I forgot. Okay, let me ask you about this. Let me change the color. So, let me ask you about this. Can you tell me something about the log of -2 in base, for example, 2? So it means that when I put the base equal to 2, it means that you need to consider the blue curve. But what do you think about this?
No real answers.
Pardon? May you repeat?
It doesn't exist, right?
Exactly. Thank you. So you see, it's important not just writing randomly things. This symbol should exist. There should be a number, then I am allowed to give it a name. If no one is born, how should I give that person a name? So there should be a person, then I can call it someone, okay? So there should be a number, then I should be able to give it a name. Why there is no number here? Because you see -2 is here. If I draw a horizontal line with the hope to find the intersection with the blue curve, it will never happen. Because the blue curve is always above the x-axis. So there is no hope that I can find an intersection point. So what does it mean? It means that not defined.
Isn't it also a rule that you cannot get a negative number from a number with power?
That is the reason, yes. That's the reason. Thank you.
Okay.
Yeah. But now let me make it a little bit more tricky to see if you remember something from exponential functions. So you remember that, now hopefully you agree with me that negative numbers are not good for logarithms. I am not allowed to put negative numbers in front of the log sign because of this thing. I will never get any intersection when I go to the negative part. But let me make it a little bit delicate question. What is your guess about log of 0 in base 2?
It is undefined.
It is still undefined. It is still undefined. Thank you. Yes. Why?
Explain why.
Yes. Yeah, you can explain why. Yes, can you?
Because 2 to the power of x can't be a 0.
Cannot be 0. If you remember, I told you that when we go on the left hand side, this blue or the red, it doesn't matter, they become closer and closer and closer to the x-axis, but they will never ever intersect the x-axis. And the reason was, as you said, because 2 to any power, even very huge negative number, it becomes negligible, but it doesn't become exactly equal to 0. And mathematics is always exact things. So log of 0 in base 2 is not defined. And I hope that you understand there is nothing specific about base 2. If I ask you what is the logarithm of -10 in base 3, it's still undefined, yes? Undefined. If I ask you what is the log of 0 in base 3, it's still undefined. Okay?
Baba.
Okay, sorry. Okay. Thank you.
Thanks.
So
I have a question also.
so let me just repeat it again. So it doesn't matter. So that was nothing particular for base 2. You realize for base 3 it's also the same. If I write negative or if I 0, there are no numbers coming out of them. There are no intersection points, so these are not defined. Yes, Gustav, now?
Can the base be negative?
Can what?
Can the base be negative?
No. We answered that before. Don't get confused. Do you remember?
Okay.
You
So
yourself
that
actually
no
answered.
number
No,
can
because
be negative when you
no,
write
because
it.
the base is coming from this base, and this is an exponential function. For an exponential function, I told you, a to power x, exponential functions are defined for positive values and not equal to 1. So we already
that
know.
means that no numbers can be negative when you deal with logarithms.
Yes. You cannot put a negative number in front. You cannot put a negative number as the base. Okay?
Yeah.
Okay, but can you tell me, let me see.
Papa,
Yes?
before you ask that, I have a question.
Yes, please.
Isn't this behavior called Asymptotes.
Yes, exactly. Exactly.
Whatever.
Yes, completely correct. Thank you very much. Yeah, that's a little bit more advanced topic, but this is called a horizontal asymptote for these functions. It means that the functions are the graph of the functions are getting closer and closer to this, but they will never reach together. Or we say that they reach at infinity in quotation mark. Okay, but which type of infinity? Left infinity or right infinity? Do you think?
Both.
Like,
No, here the closest is happening on the left. Here they are not close, they are far away from each other. But as far as I go to the left and left and left, the distances between the curve and the horizontal x-axis become negligible. So it means that if you want, some books write something like this, which is understandable now. Some people say it is minus infinity. Okay? Yeah, sometimes that's also plausible, but this is not 100% precise. But if you see it, at least you understand why people write minus infinity when I have 0 here. Because apparently the touching point will happen on the infinity on the left hand side. So that is called minus infinity. Of course, minus infinity is not a point that I can show it, but this is a behavior. It means that it is smaller than any possible negative number that you can imagine. Okay, don't get confused, but these are very important things that I want you to learn. You'll learn very good, but you need to try to review the videos, not to forget. You need to send them to your long-term memory. Okay, now one more thing. Because Gustav asked me a question, then suddenly I realized might be it is good to talk about. Let me ask you something. How should I ask? Okay, let me start with a log. I put a base 2 for you. If you don't mind, let me go to the previous picture that we have only this one, and let me make it bigger here. So my question is that I write log, I put base 2, and I put a question mark here, and I am asking you, based on this graph, can you put any number that you like? Can you put a number instead of question mark so that the output is guaranteed to be negative? Even if I don't know the exact value, I don't care. But I want to be convinced that the whole number is a negative number. This is different from Gustav's question. Gustav asked, can we put negative number? I said no. Can we put negative number here? I said no. But I didn't say that the output can be negative or not. Now I am asking you, do you think that I can put something here so that if you calculate the whole package, the package becomes a negative number? Yes or no, and convince me of that.
As long as it's smaller than 1, right?
Yeah, exactly. You give the best answer. Actually, you gave the best answer. Yes. Let everyone thinks about it. Everybody agrees?
Yep.
Yes. Why is that? Because if I choose a random number between 0 and 1, okay, let me make it even bigger. If I choose a random number here, okay, my goal is to continue to intersect the curve. There is no point to go to the right. The distance is getting larger and larger, so there is no hope for intersection at all. So what about going in the other direction? Yes, if I am patient and go to the left, finally I will find this intersection and I will go down. This is the logarithm of that number. And definitely this number is a negative number because it lies between -1 and -0.5. Okay?
And we're not talking about the base here, right? We're talking
The
about
base is 2. No, the base is 2. I am just talking about the blue curve. When I'm talking about the blue curve, because the base is 2, the base is also 2. Yes? So you see that it doesn't matter, at least for this, you can choose 1/2. For example, take this one and put 1/2. If you know how to calculate this, by the way, you should be able to calculate this exactly. Okay? What is the answer to this? Question after question is coming to my mind. Okay, so what is the log of 1/2 exactly?
-1.
Yes, it's -1. Why is that?
I don't remember.
No, but yes, exactly, because you see this 1/2 is here, because 2, if I ask you what is 2 to power -1, what is the answer? 2 to power -1 is 1/2. Okay, so this I go here and then I go here, so this is 1/2. So when I have -1, I go and reach to 1/2, so it is clear that if I start from 1/2 and go to the other direction, I will reach to -1. So the answer to this is exactly -1. But don't worry about these things. What I want you to understand is that if I put 1/2 here, the output answer is negative, and in this case happens to be exactly equal to -1. So my point is that even though I am not allowed to put, and if I write a logarithm, even though I am not allowed, so let me write it in this way, log of b in base a, I am not allowed to put a negative number here, I am not allowed to put 1 here, I am not allowed to put a negative number here, but it is completely okay if the output is a negative number. This can happen. Okay? Now, yes?
No, I agree with you.
Okay. Now let me try to motivate you here. Can you tell me, if I want to make life simple, tell me what is happening. When I say log, let me see. When I say log of 3 in base 2 is equal to y, can you tell me what is the meaning of this symbol? Let me describe myself a little bit. When I say that y is equal to the square root of 2, what does it mean? You tell me that y to power 2 is 2. This is the meaning of saying y is equal to a square root of 2. Now, can you tell me, when logarithm of 3 in base 2 is y, what is the meaning of this? How can I translate this into the language of powers? This is not a power. What?
Baba,
Yes?
I would say that y is the exponent and 2 is the base.
Yes? And then 3 is?
Equals to 3, yeah.
Yes, 3 is the answer. Yes, exactly. So this means that 2 to the power of y is equal to 3. Okay, so the reason that I am able to calculate these things fast in my mind, because I am not using these things, I am just using this definition. So when you say that log of 3 in base 2 is a number, it means that when I raise 2 to this, it becomes 3. So I don't know, remember this symbol, yes? I don't know, this is the way that I memorized it when I was at your age. So this to this power, it becomes this number. This to this power, it becomes this number. So don't get confused. So for example, tell me, log of b in a base a is equal to c. How can I translate it in the language of powers?
A to the power of c is equal to b.
A is equal, yes, exactly. And this is what we define as the logarithm. You see, so if you understand what is going on, you discover all these things. But if you look at the mathematics book, they say that this is the definition of the logarithm. So mathematicians are like that. They do a lot of scratch paper work. You see, these are all scratch paper works we did today. Yes, not that many. Okay, I made it bigger. But at the end, this is the final conclusion, and then write it very clean. And then after learning that, I don't know, I would say that it should go to your long-term memory to use it over and over again and more quickly. Okay, so now everyone hopefully agrees that this equation is equivalent to this equation. So if you want to see that if this is true or false, you translate it into the language of powers that you already know about it, and then check if this new one is true or false. If the new one is the exponent one is true, you say this is also true. If this is false, this is also false. For example, let me now tell you, can you tell me what is the log of 8, 2? If you can do it in your head, good. If not, let us call it x. I don't know x, I want to calculate x. But immediately what happens? It means 2 to power x is supposed to be 8. But now, can you tell me what is x? X is 3. So this means that if someone asks you what is the log of 8 in base 2, the answer simply is 3. Do you agree?
Yeah.
Good. Now, if I ask you what is the log of 20, no, let me make it like this. What is the log of 32 in base 2? If you can do it in your head, that's okay. But not, if not, you say that I want to find this. This is my question mark. So let me call this x. I still don't know x. But I know something. I know the definition of the logarithm. If this is the case, this would imply that this symbol, you see, this to this power is equal to that one. So this means that 2 to power x is equal to 32. And hopefully you know 32 is 2 to power 5. And then you compare these and you conclude that x is equal to 5.
Can you write your little thing again?
What do you mean?
The way you remember it. Can you draw that again?
Yeah, so I'd say that log of a is equal to c. This one to this power is equal to that one. I don't know. This is the way that I memorized it. This is stuff I don't know even why. Yes, but this is the way that I learned that.
Yeah, they call it the log method. Like it goes around like a log.
Ah, okay. I don't know. But anyway, it's up to you. How do you want to memorize that? Okay, is that okay now?
Yep.
Now let us make it a little bit more challenging. I'm just going through I will organize everything next time formally. But it is extremely important to understand the concept, because if you understand the concept, you can discover methods yourself. But if you don't understand it yet, you have to memorize, which is not a very good thing. So you see, I have to find a balance. I am a fan of memory, but not just memorizing blindly. Memorizing after solving a lot of problems, that's a good way to do it. Okay, so let me ask you this question. What is the log of 100 in base 10?
It's 2.
It is 2, yes. Why? Because 10 to power 2 is 100. Now, there is a convention. If the base is 2, we don't write it. Sorry, if the base is 10. If the base is 10, we don't write it. It's exactly similar to this. Do you remember when we write this, you know that there is a number here. When you don't write something, what is that number there?
2.
It's 2. So by convention, if you don't write something here, it is 2. By convention, if you don't write something here, it is 10. So nobody writes log of 100 in base 10. People write log of 100. Just that's it. And then what is the answer? The answer is again 2. Because you need to imagine yourself that the base is 10. Okay, now let me ask you one more question. So what is log of 1 over 16 in base 2? So, but let me ask you, please predict before calculation. Let me make this one clear. So predict before calculation. Do you expect a positive number or a negative number based on this?
Negative.
Yes,
Negative number.
yes, very good, very good. You see, so this 1 over 16 is here, somewhere here, and if I go here, there is no hope that I intersect on the right hand side, but definitely if I start continuing, at some point I will intersect on the left hand side. So definitely it's a negative number. Very good. But let us now calculate it without calculator precisely. It might be hard in the beginning to guess this number. You don't need to guess. This is the reason that I taught you exponential functions, exponential equations last time. Yes, please? Someone wanted to say something?
-4.
It's -4. Yes, exactly.
Yeah, -4.
Yes, yes. But if you cannot calculate it mentally, you say that, okay, my question is this. Usually in mathematics, instead of question mark, people write x. And then you remember this diagram. This to this power is equal to this number. So then it means that 2 to power x is equal to 1 over 16. Then you see that this is not a new problem. This is a problem we practiced a little bit under the title of Exponential Equations last time. Okay, so how should I solve that? I need to write both sides in the same base. This I cannot do anything with that, but if you're a little bit friend with numbers, you immediately realize that 16 is nothing except 2 to power 4. But of course 2 to the power 4 can be brought up. Instead we can write 2 to the power -4. And then I still compare these two, and then I realize that x has to be equal to -4. And then the answer was exactly what Rocco mentioned, so that's correct. Okay? So let me see. Let me see a little. Can I give you some? I will definitely start formally these things later, more organized way. But I hope that you learned a lot actually at this session. Okay, let us do these things. If you can calculate them mentally, okay. So what is log of everyone, okay? What is the answer? Everyone. It's 2, yes. As soon as the first one says, I will write the answer. So start competing, okay? What is the log of 1000?
3.
It's 3. Why? If someone asks you why, the reason is that 8 to power 2 is 64. If someone asks you why, you should say 10 to power 3 is 1000. Why 10? Because 10 is not, the base is not written by convention, it is 10. Okay, can you tell me what is this one? It's a little bit more, no, not tricky. So let me write this immediately. Yeah, it depends how much you know about numbers in your head. What's the answer to this?
6.
No?
It's 4.
It's 4. Why? Because 3 to power 4 means 3 times 3 times 3 times 3 is 81. Okay? But you understand the concept, okay? At least. So what is the log? Can you tell me this one? 0.001.
-3.
-3. You are not, I hope that you are not calculating with calculator, yes? By the way, you have to learn how to calculate with calculator. There is an unfortunate thing. The calculator has only this button on it. Okay? Then I will teach you later, if you want to calculate the log in any other base except 10, how you have to do it. Please go to your calculator and find the LOG button there, and you have only access to LOG in base 10. I will teach you later that how you can use calculator if you want to calculate log in any different base, in any base different from 10. Please go and find that, and just right now, if your calculator is available, punch this in your calculator and then confirm that you, as you said, get -3. This is crucial. I want you to learn how to use calculator as well. Do you have your calculators with you?
Yes.
Yep,
Okay.
Yeah, I
it's
checked it.
correct.
Okay, good. So, but you don't find this. Most of the calculators you will not find log in base other bases. So, how you should use your calculator? Use to calculate this. I can immediately tell you here, but you don't know the reason. I will teach you the reason later. You can write log of 81 divided by log of 3. If you want to use your calculator, you write log of this one divided by the log of this one. It's a little bit a strange reason. You will see why this is correct. If you calculate this with your calculator, hopefully you get 4. Please confirm that.
Yes.
Good. Let me make you one more question. Can you tell me what is log of 8 in base 4? Not with calculator.
Oh, 302.
Okay, can you describe how did you come to that answer?
What is it? The second root of 4 is 2 to the power of 3 is 8.
Yes. Okay, so you know what you are doing. But if you want to describe it to someone, how do you describe it? I would say that okay, it might not be easy to guess. So I want you to be able to do it yourself. So you give it a name. This is your question mark. In mathematics, usually question marks are replaced with X. You need to find X. Mathematicians are looking for X for millennium actually, but they couldn't find X. They are busy. That's good, yes? So probably you can find X at some point. And then you have the definition 4 to power X is equal to 8. I hope that everyone agrees with me up to this point. Yes? But now,
Yep.
but now this becomes the problem that we studied on Monday. This is an exponential equation, and if you're a little bit friend with numbers, these are related to base 2. So what I can do, instead of 4, I write 2 to the 2, and then I have a power of x on top. Instead of 8, I write 2 to the 3, and then what happens? It becomes 2 to the power of 2x is equal to 2 power 3. Then it means that 2x becomes equal to 3, and as now you said, very good, the answer is 3 over 2. Might be some of them are not easy to guess. If that's not, you shouldn't be in a hurry. You just write equal to x, use the definition of the logarithm, and try to find the value of x. Okay? Is that understandable?
Yes.
Okay, so let me ask you one more question here before the lesson ends. Let us put this one. Next time on Friday I will start this a little bit formal and start doing it. Logarithm, I remember when I was at your age I enjoyed solving log problems a lot. You have to be very creative sometimes to be able to solve those problems. But don't worry, those are not at the level of the book, so they will not come in the exam. But it is very fun to learn this, to learn mathematics not for the exam, for changing something in the future. So
I have a question.
yes.
It's about the exam.
Yes.
These questions we've done so far.
Yes.
What level is that?
No, I would consider them mostly E-levels. The book doesn't talk about concepts that much. So from concept points of view, they are high levels. But when it comes to calculations, these are simple questions. They are not hard. For example, this might be a C-level question. Or the other one, this also is C level. This is not This is not E level. This is considered to be C level. This C level. Okay, now can you tell me what's the question mark here to finalize today's session?
Three.
No,
It's 4.
it's 4, yes. If you cannot calculate it in your head, again, let us use the method. Instead of question mark, I put x. Then what happens? It becomes a square root of 5 to the power of x is equal to 25. But if you are a little bit friend with numbers, you immediately realize that 25 is related to base 5 in this form. Can you tell me how square root of 5 is related to base 5?
Well, 5 times 5. No, sorry.
No.
Square root of 25
times
is 5.
5 is 5.
No. I want you this. I don't understand. I don't. So I have to force you memorize this. You see, if you don't have it in your memory, there is no hope to solve this problem at this point. The nth root of a can also be written as a to the power of 1 over n. So I decided I will never give you formula sheet next year. Formula sheets are thrown in the basket, okay? So I think because you are losing your knowledge because of that damn formula sheet, yes? So how many times I should tell you this? If you can remember my face, assume that this is also written on my forehead. It's not hard to remember that. Now, can you tell me, what is the square root of 5?
But it's the 1 over 2. It's the 5 to the power of the 1/2.
Yes. So if you don't know this, there is no hope for solving this problem. Of course, there are some hopes, but you have to start everything from scratch. Okay. So what I do, instead of this number, I put this number. So it becomes 5 to the power of 1/2 to the power of x. On the right hand side, instead of 25, I write 5 to the power of 2. And then you know that 5, this is an exponent raised to another exponent. So it becomes 1 over 2 times x is equal to 5 over 2. So 1 over 2x is equal to 2. I want to make x alone, so I multiply by 2, and I will get x is equal to 4. Okay, so it's extremely important that you remember. I think, yes, if you want to have me your teacher next year, no formula sheets, no calculators, yes?
Whoa,
Yeah.
stop.
Okay,
We're gonna have calculators, not the formula sheet.
Yeah.
Nothing,
Come on.
yes. We go back to ancient times, you know.
No, I'm fine with no formula sheet, but calculator.
No, of course, if I don't give you calculator, I will design the questions that you don't need calculator. So, for example,
Okay.
for this question, if you use calculator to solve this, give me answer 4, you get 0 points. Because if I give you the exam, and even if the calculator is allowed, you give me the answer 4, it's 0 points. You have to demonstrate how you reach to x to the 4. So calculator is not a big obstacle in front of you because you use it when you need it. But formula sheet psychologically prevents you from remembering important stuff, you know. If you don't remember this, it's not easy to remember to do it from scratch. Okay, so there is no hope to solve this problem. Yeah, so
I
try.
just want to say, for the record,
Yes.
I don't look at the formula sheet and I still don't remember anything.
Okay. Yeah, we have to find a way because I think this is the enemy in here in Swedish education. Because I am completely sure that you learned more or less. I would say you learned 80%. By the way, you know that we have a short memory and a long-term memory. So if you do not repeat what you learned in an interval of at most 24 hours, 90%, research has shown, about 90% is gone. Okay? So you have to repeat. So the Anki webpage, the Anki, or I don't know, one of those tools, is exactly the algorithm there is because you have to be able to send what you learn, and it is still in your short memory, and transfer it to your long-term memory. If you don't do this process, you have to, I would call it suffer. You have to put time. I don't know, if you like mathematics, that's not suffering. If you want to learn, there is a process. You need to appreciate the process. So you need to go back to this lesson at most in an interval of 24 hours from now. At least review some parts of the video, and I don't know, some notes, do some exercises. If you don't do it, then you mostly will forget 80% of that in 2 or 3 days. So this is what I want you to be able to learn, because that would be a pity. You are spending a lot of time to be in a school to learn these things under these circumstances. You learn very good, so what's the point? So keep it with you. Why do you want to forget about it? You need to just work a little bit more to review it properly, algorithmically. I think next year I will force you to use Anki, so might be I can also make you some flashcards and then force you to remember them. Yeah, you need to start using your memory at some point. It's a valuable tool. Consider that you have a computer without any RAM. Your RAM is good, but your hard disk, you don't have any hard disks, I think. Do you? Yeah.
No,
Yeah.
no.
So you need to improve your hard disks. Your RAM is working good actually. Yes. Okay.